Hey everybody, welcome. Welcome to the lecture. So today we are going to be implementing a linked list together in Rust. It's going to be a great adventure. And yeah, this is also my first time live coding, so that's going to be interesting too. I'm going to try to go slow. I'm going to pause a lot for questions, and I want you to please interrupt me if you have any questions as well. In order to do the live coding, I'm going to share with you all this thing called Rust Playground, which is actually a Rust, I guess you could sort of like, it's a way to like run Rust code in your browser. And it's super helpful because you can share little snippets of code with people. I think y'all might have seen it before. I've used it in the Slack. But then afterwards, I can actually share this link with you and you can like play around with it yourself. So it's also super convenient. So before we get started, are there any questions about anything? So we're going to see a lot of ownership and borrowing stuff pop up in like just this example using linked lists and everything. So if you feel like you want more practice with that, don't worry, we'll definitely get a lot of practice with that. Okay, so I guess without further ado, I'm going to share my screen. Let's see, how do I click this button and I say this one. Great, okay. Can people see that? Okay, great. So, right, so now how do we get started? Right, so first of all, so this is also just going to be our first introduction to object-oriented Rust. And so Rust allows you, like C and C++, to have structs. But the cool thing about Rust structs is that they sort of enforce this idea of type safety. I'm not going to go too much into what type safety means for the purposes of this lecture because I'm trying to just introduce these concepts in terms of like how you'd use it. But like the gist of it is you can't, for instance, like do like an invalid cast or something. You can't reinterpret memory in unsafe ways. And oftentimes these are common errors that happen in languages that are not type safe, like languages like C, for instance, where you can misinterpret a piece of memory and you end up just like sort of populating your struct with garbage values. So this is another nice feature of Rust that kind of ties into the memory safety a little bit. I'm not going to talk about that too much though. So the first step when we're constructing our linked list is we need a definition for our node, right? And our nodes are going to be heap allocated. So I'm going to quickly show you how do you like allocate things on the heap. Does that sound good? Great. Okay. So if I want to allocate something on the heap, I use this thing called box in Rust. It's kind of like unique pointer in C++. You might not have seen that before. That's okay. It just means that I'm going to have a pointer to heap memory, and this is the only thing that is going to be pointing to this heap memory. So what this means, so I guess like could someone quickly like answer like why is this useful? Why do we want to ensure that there's only one pointer to this heap memory? What does that mean? Like why is that maybe relevant? Does anyone have any ideas? Like that might have to do with ownership, right? Like how does that interact with what we've been talking about for ownership? Feel free to unmute yourself. So if I guarantee that this object contains a pointer to heap memory, like what happens when the object goes out of scope, for instance, maybe? Exactly. It will auto free because there's this function called drop that gets called when an object goes out of scope, right? When its lifetime ends. And then that way we don't have to worry about memory leaks for boxes, and it will auto free itself. We don't have to worry about double freeze either because we can't manually free ourselves. Freeing is fundamentally an unsafe thing that Rust will prevent us from doing with that. So yeah, so that's great. So an example of how you use the syntax is I could say like let x, say it's like a U32, or actually the way I'm going to annotate that is I'm going to say it's a box containing a U32. So this is kind of like the vector syntax we saw before. It's going to equal box new of say 10 or something like that, right? And then I could do something like println bang as a format string x, and we're going to see what this does. So we can run it right in our browser, and what is it going to say? It prints out 10. Another funny thing to notice here is if I do star x, what do you think it's going to print out? Well, let's take a look. It also prints out 10. That's kind of surprising, right? So this is kind of like one of the quirky things to remember about Rust. It kind of auto dereferences things for you sometimes. Other times it doesn't. Kevin asked a question about this on the Slack, which was a great question. The internals of how println works, we're not going to talk about it too much yet because it's a macro. It's a little bit more complicated, but it kind of knows to like auto dereference things like integers in order to display them. And later on, when we look at actual structs, we're going to see how that plays out as well. So I guess without further ado, let's get started and let's try to define our struct, right? So the syntax for defining a struct in Rust looks like this. So I'm gonna have a struct node, and first of all, okay, y'all have probably made linked lists before. What needs to go inside of this struct? Somebody help me out here. I'm gonna make this interactive. I'm gonna go crazy if I just hear my own voice. Okay, forward and backward is great for doubly linked lists. Doubly linked lists we might talk about a little bit later because they're a little bit fancier in terms of how the pointers work. So what if I wanted something simpler? Exactly right. So we'll have like our value. Let's say it's just going to contain U32s. You might be wondering, what if I want a more exciting linked list that can contain anything? We'll talk about that a little bit later next week when we talk about generics and traits and stuff like that. But for now, we're dealing with integers. We're great with integers, right? And then you say we should have a forward or like a next. What type should this next have? What do people think? Okay. Well, I showed y'all how to make something that's a heap allocated pointer, or I guess a pointer to something on the heap. So what might you use there? That's a great idea, right? So we do next box containing a node, right? So it would be a box of node, something like that. Does that look good to everybody? Right. So
Here's a quick question I just thought of. So
yes,
like a box is a pointer, right?
yes.
But we've been talking about how references are also kind of pointers. Why couldn't you have a node ampersand here? Can anyone answer that question? So yeah, you would be borrowing. And more importantly, uh, does anybody know what would be wrong with borrowing? Like borrowing works in other parts of Rust. Why can't we borrow here? You'd be borrowing like a node.
I think the idea would be doing
So
something like this, right? So does
so
this
without the box, just next colon ampersand node.
yeah. So look at the compiler error. It actually says expected named lifetime parameter. This might give you a hint of what the issue could be here.
That's exactly right. Like, if you want to borrow a node here, who are you going to borrow it from?
Yeah.
You have to ensure that that node survives for the lifetime of this linked list. And there's no good way for Rust to guarantee that like that ownership is going to survive for as long as you need it. And so we actually need to own the node here. And that's why we put it inside of a box. A box is a pointer. It's an owned pointer to somewhere on the heap. And it's going to survive as long as the box survives.
So like a nuanced thing I want to point out here is like the Rust compiler is actually so nice. It gives you a suggestion for what you should do, but sometimes you don't want to follow these suggestions. So here the Rust compiler is saying, oh, you need to do a lifetime parameter, right? So I could write my code like this where I say tick A. Tick A is essentially a variable saying like this node is going to live as long as A. A is like a lifetime, right? And then I could say tick A, like ampersand tick A or something like that. And if I do that, it is still angry. Node, sorry, it has to be node of I guess ampersand. This would be next box. So I think it would be something like this actually. You have to do something like this actually, which is, okay, we're not going to talk about the syntax for a while, I just wanted to show you here that this is an example of how you can communicate to your code. I'm going to promise that it's going to live at least this long, but this is not what we're doing today. I understand if like this might have been a little bit confusing to show you, but I just wanted to give you an example of you can communicate to the Rust compiler how long these things should live. And this is something that we'll actually see a little bit later on, but that's not what we're doing today. So that's why we're going to have it owned as a node, just like that. So just forget I even said that. That was kind of just more of like a little bit of an advanced point there. But this compiles just fine. And right, this is great. So like my linked list, how do I know I'm done? My next is going to have a null in it, right? So does that feel wrong to anyone with the current setup we have? Like, what did we just say about null pointers? Like, can my box, can I do a box? Can I do like box : null? Does that make sense? No, right? So what do I have to do? What tool do we have to use that we might have seen recently that Ryan introduced last lecture? Exactly. So I'm going to say next is an option of box of node. And it looks like that it's kind of a mouthful to say option of box of node. Rust actually lets you do type declarations and type definitions and stuff like that. I'm not going to show that right now. Maybe I can like provide a link to an explanation of that in Slack. I just don't want to like bombard you with too much new information. But for now, and I also just want us to like sort of let that sink in. This is an option containing a box of a node. Are there any questions so far? Okay, great. So then now what do we do, right? So now we actually have to implement our linked list, right? And say our linked list is going to linked list. Okay, linked list, we want it to contain, you know, some sort of head, and we want it to contain, let's say a size. We want to keep track of our size. So as you see, the size should be stored as a usize. This is the syntax. Remember, it's a colon on the left hand. On the left-hand side of the colon, you have the variable name. On the right-hand side, you have the type. So what type should the head be? What do y'all think? Exactly. If we just had a node, we're promising that our linked list is at least size 1, but it's going to start out empty, right? So it should be an option of a box of a node. Exactly. Does that make sense to everybody? And now I'm going to show you sort of like the object-oriented syntax for implementing like functions on these objects. So the way you do this is you'll say something like impl node. Let's start with node. And the way I'm going to do this, I'm going to say public function new is going to take in, so we're going to create a node. What should I pass to my new function? What do y'all think? So this is my constructor. I could have named it anything, but I'm calling it new because that's just convention and that's good style. So what should my constructor take? Like if I'm trying to make a new node. Right, so value is a U32. And okay, what else maybe? I guess we have two things in our struct to fill in, right? What's the other thing we need to specify to have this be like a nice, well-defined node? Exactly. Thank you. So we'll have next, it would be an option box node. And then, right, so we have that. And okay, and then let's see. And then I'm going to show you the syntax for constructing a node, right? So we'll do the way the syntax looks is it will be node with the brackets. So kind of like our struct definition, except on the left-hand side, we'll have, again, like the variable name. On the right-hand side, we'll just like plug in what value we want there to be. So I know this looks a little bit funny because like it's called like value, it's like value used twice, but the value on the left-hand side is the struct member. It's important to remember. And the value on the right-hand side is from our actual parameter, right? So it's like value, and then next would be correct here. Does that syntax make sense to people? So this highlighted portion is the name of the struct. Look how it actually highlights in the struct. This highlighted portion is the name. I guess it's highlighting all the values in the program. And this highlighted portion is the actual parameter. Does that make sense to people? Another thing
Because like the 106 is we always say like if you make it the same, it's kind of confusing. So we prefer that you make it slightly different.
So I've seen in Rust code bases people doing stuff like this, and like I think it's fine. I feel like if you were to call it something like temp value and temp next, for me it's like I think it's like a matter of personal taste, but I think it's fine because like this new function is very simple, right? It's literally just taking all of our parameters and it's plugging them into the little members of the struct. So I think it's okay to do this. But in other cases, you do want to like kind of differentiate your variable names. That's a good point. That's a great question that we will answer soon once we start defining methods on our node or on our linked list that can actually modify things. So it depends like what kind of a reference do you have to your node. If I have a mutable reference to my node, then sure, I can start changing things around. If I have a shared reference, like a shared borrow to my node, then I can't do that. But that's a great question. So you're already thinking one step ahead there. Another thing I want to like notice here is that we don't have a semicolon here. This is because this should actually be returning something. So I forgot you need this arrow, and you're going to say this is going to be returning what? It's going to be returning a node, right? So if I had a semicolon here, there's actually going to be a compiler error that you will see. Compiler error is going to say mismatched types. It says expected struct node. It found this empty parentheses. So these like this empty pair of parentheses is something called the unit type. You don't have to worry too much about what that means, but that's basically, it just means like nothing, kind of. It's different from the none of option. It just kind of means that like, it's void. You should think of this as a void, basically, more or less, right? So this means so when you put, when like in a function, like what the last expression in the function evaluates to is what the function returns. So if I put a semicolon, that makes that expression evaluate to void. It makes it evaluate to the unit type. Here, I remove the semicolon and it's happy with me. Does that make sense? Okay, great. So we do the same exact syntax for linked list, right? So now that y'all have seen the syntax, can somebody tell me what I need to type here? Someone's just sort of like narrate for me, help me out here. So to remind you, the linked list looks like that. Maybe I should close this actually. Great, now you can see all of it. So what do I need to type here? Exactly right, so head is going to be of type. Okay, well actually, let's say we want to initialize an empty linked list. What should I do? Let's say our new doesn't take in any arguments. It should initialize to an empty linked list. First of all, I'm missing something here. What am I missing? Exactly, the return type is going to be a linked list. Okay, and now what am I missing here? What do I need to, what should this be? What is an empty linked list? Exactly, so we're going to set, so head is going to be none, right? We don't have a head yet. We don't have a node yet. And the size is going to be 0. Does that make sense to everybody? Any questions about that? So let's just run it to make sure it compiles. Run, okay. Great, so that compiles, it outputs 10 because we still have this here. We're going to get rid of that soon. Great, okay. So now let's go forward. Let's make this a little bit more interesting. So we've defined our new function. Let's define is empty and get size. So let's define get size first. So this is going to be interesting because this is going to incorporate a little bit about what you know from borrowing, right? So I'm going to say there's going to be a public function get size. And like Python, there's this self keyword. So I'm actually going to say ampersand self, and then I'm going to say, right, that's the only parameter it should take, right? And what do you think should be returned here? Like if you had to guess what the syntax would be, what do you think I would type here? Like, what's the most intuitive thing? Maybe for those of you who know Python. Like, if this were Python code, what would I type? Exactly. Thank you, Michael. So it'd be self.size, right? Oh, yes. Okay, that's all. Thank you. You caught that as well. Usize. Arrow usize. Great. But okay, so that kind of reminded me of something else. So self is a shared reference. A shared reference is kind of like a pointer, and normally we dereference pointers. So first of all, let's see if the compiler is happy with us when we do this. So if I do ampersand star self dot size, what does it say? Do you think it's going to be happy with me? It is happy with me. It thinks that's great, right? But it's warning me that get size is never used. The funny thing is that if I just take this away, it also works just fine. This is because Rust, when you're accessing a struct member, it will dereference it as many times as it needs to in order to get to like the core of that struct member, which is weird. I understand that that might be like non-intuitive. This is more of just, you can think of it kind of as like syntactic sugar, but this is just something to keep in mind. Like idiomatically, it's better to like not explicitly dereference things if you don't need to. In certain cases you will, like if it's kind of like a little bit of a tangent, so if you have like questions about that, maybe save those for after lecture, because I want to like make sure we get through all of this. But like an example would be like if I'm iterating through a vector of integers, my iterator is going to be a pointer to each thing in the vector, and it's going to be a pointer to an integer. And if I want to like increment that value or something, if I had a mutable iterator, then I would have to do like star, and I have to like increment it or something. You might have seen that in the previous week's exercises. Are there any questions so far? So for now, just remember that it's smart enough to know how to dereference it, right? So now if I want to do like public function is empty, right? First of all, what kind of a reference do I need to self? Like, what's the first parameter? What do people think? Yeah, exactly. Ampersand self. Great. A lot of people said it. And what is this going to return? It's going to return like a Boolean, right? And then I will say, so there are multiple things I could say here. Someone have a suggestion? So self.size equals 0. Like, let's see, is it happy with that? Yeah, so it's happy with that. Another thing I could have done I could also say, we could say head.isNone. I'm just showing you different possibilities. I want to also show you that you can call functions for the class from within the class. I can say self.getSize is equal to 0, right? Now, this might not be the most idiomatic thing because like, why do we need a function call if we're already inside of the class and we already have like size, but I just want to show you that this is also possible. Like you might want to be calling functions from within the class inside of the class. Does that make sense to everybody? Great. Okay. Okay, great. So I just want to show you some syntax for how we'd actually like get started with constructing this. I could say like let list of linked list equals, what do you think what should I put on the right hand side of the equal sign? I don't know if do y'all remember like if you're defining a new vector, if you're defining a new string, like what sort of syntax you use? Exactly, it'd be linked list : new, right? Oh, it was angry. Oh, it's because I forgot a semicolon. There we are. It's classic. Oh, and it's also because I deleted X, obviously. No, I'm sorry. Great. Let's see. What does this do? Great. so it doesn't output anything. So yeah, so I could do linked list : new, and to test my functions, I could say something like println bang, and I'll just say, we'll try to display what happens when I do list.isEmpty. Let's see what that outputs. It outputs true, right? Do you see that down there? So it actually knows how to display things like true, which is pretty cool to think about. We could also do something, I want to show you, like in Rust, when you're trying to assert your code, like do assertions for tests, you can do something like assert bang list.isEmpty. This is like a useful thing to know when you're writing unit tests in Rust. So if we do that, it's going to be just fine. But if I did not is list.isEmpty, what do you think happens with the failed assertion? It should panic. It should crash my program. Actually, wait a second, it does not. That is interesting. Assert bang. Wait. Oh, it seemed to be okay with. Oh, sorry, no, it does. It said it did panic. So it did fail. It printed out something, then it panicked, right? So do you see that? It said thread main panicked at assertion failed. So this is how you would write unit tests and stuff like that. If you want to show that your code, like say we want to test get size now, we could say assert EQ bang. So this is like asserting equality between list.get size, and at this point it should be 0, right? So we could say something like that. And that didn't panic, so we know that all of our assertions must have evaluated to true. Just note that I removed that negation there. Does that make sense so far? Does this syntax kind of make sense? There's a lot of new syntax. Totally okay if some of it's confusing. It'll definitely be seamless. So we can identify them as macros. So what you do in something like C is kind of like a stylistic thing where you'd make everything in all caps, and that was supposed to signal to people that this is a macro. Because like the way the macros work is they kind of just like find and replace things, right? Like that's what the preprocessor will do for like compilation. But Rust, like this is actually built into the language. Like I can't define a function that has an exclamation point in it. Does that make sense? So this is like a much safer way of doing macros. Rust macros are actually super fancy and interesting. There are lots of cool things you can do with them. But we're going to be talking about that a little bit later on. But that's a great question. Yeah. Are there any other questions right now? Okay. So I guess before our list gets really exciting, we start pushing and popping things to it. Let's all just take like a quick 1-minute break. It's like get up, stretch, like do whatever you need to do. Sort of like, we've all been sitting down. Like 50 minutes is a short amount of time, but it's also a long amount of time. So sort of do that. Reset yourself. Okay. All right, just a really quick it's like reminder to get moving. Maybe go outside today if you haven't gone outside. That's really important. Wear a mask, obviously. Be safe, but try to get some fresh air for sure. Great. So now our linked list isn't too exciting. We just made an empty linked list. There's not much going on there. Let's actually start adding things to it, right? So I'm going to define a function called push, right? And public function push. Can somebody tell me what I should write next? And so maybe like using what you might know like about borrowing, ownership, stuff like that. What should I write next? Ampersand self, okay. So push is actually going to be changing our list too, right? So how do I type that? So ampersand mute. The same thing, yeah. So y'all might have seen this on the assignment even last week. You'll definitely see it on the assignment this week. So it'll be ampersand mute to self. So it's important to realize that like something like C++ lets you do this. It's just like you put like const after like I guess like the name of your method, and this is like saying like a promise that I'm not going to change anything about the state of the class, right? But here in Rust, you have to be explicit about like, is this going to be immutable or is this going to be a mutable function? So because push, we expect to change things in the linked list, we need an ampersand mute to self. We kind of need a little bit more than that. So we need the value that we're pushing. So we could say something like, value, it'll be, we're storing U32s, right? So are we storing U32s? Oh, we're storing U size. Wait, no. Yeah, we are storing U32s. Great. Okay, what goes next? What do I need to do? So let's refresh our linked list mechanics. What do I need to do? It's like the first step. Like if you were writing this in C or Java, like what would be the next line? Exactly. So how do I make a new node? Do you remember? First of all, what's the type going to be? Let's annotate the type. Exactly. And how do I make a new box? Box : new. And what do I put inside of this box? A node. Okay, how do I make a new node? Right, okay, great. So it'll be node new. And what's the first parameter? Right, so the value is going to be that value. What's my next now? So let's look at this definition, right? So the next is going to be an option box node. Let's say I want my linked list to have constant time insertion and deletion, constant time push and pop. Maybe the names push and pop are kind of suggestive. Let's say this is going to be a stack, right? So what does this mean for the next pointer? Well, okay, yeah, so it could be none. But if we're just moving this to the front of the list, what do we do? It'll be a head, right? So how do I refer to that head? Head. Okay, right. So first of all, let's just make sure that compiles by itself.
So this is actually ending up being a stack instead of a linked list. It's a linked list stack.
I mean, a linked list independent by, yeah. So it seems to be angry here, right? So it does not implement the copy trait. So how do you think we could fix something like that? This is kind of an issue, right? We wanted the head of the linked list, but we have a mutable reference to it. This is kind of a problem. So the Rust compiler has a little suggestion, but I'm going to say we're going to ignore that suggestion for now. Yeah. What are thoughts people have?
Does anybody have a sense of why there's an error here?
Yeah. Yeah, exactly. Like that's what the compiler says. It says head does not implement the copy trait. You can't just copy it. And it's also saying you can't, like what we'd like to do is we'd like to transfer ownership, right? And that's kind of tricky because we have a mutable reference. And how do we convert a mutable reference to like an owned version of something? This is an unfair question of me to ask because like you haven't learned it yet and I haven't showed it to you, but I'm going to show it to you right now. So if I have something like, let's say I'm going to I'm going to have something like let x is going to be, it's going to be an option of a U32, and that's going to equal sum 5. Okay, and I'm going to let y, let's be like x ref is going to be ampersand mute to an option U32. and that's going to equal ampersand, sorry, I have to say let mute x, right? Don't want to make an error there. That's going to be ampersand mute of x, okay? So far, so good. So let's just like convince ourselves that this by itself will compile. I'm going to comment this out. So that this by itself is valid. So this by itself is valid, right? There's this function I'm going to introduce to you called take. And what take is going to do is it's going to convert this mutable reference of the option to the value, to the option itself. It will like return like the option itself, and or I guess like the value inside of the option, and it'll leave none in its place. Or sorry, it'll still be the option. It will convert basically this ampersand mute to an owned option. I will show you a code example of what this looks like. So what I mean here is like if I do something like result of take, it will say I'll do xref.take. This is what calling it looks like. And then if we do println bang of like what's like left at x, this will be x. We'll actually see how this works. And I'm also going to comment out this true. I'll just delete that, honestly. So we're going to run this. And let's see how this works. Oh, it got angry at me. What did I screw up? Because I put I got a little creative with my exclamation point. I put it on the inside of the function. Sorry about that. All right, let's take a look now. Now it still doesn't compile. Okay, so it's saying I don't know how to display options. I'm going to show you all a little trick. I could do debugging like this. I can put a colon, question mark, and that's going to display the option for us as a debugged value. It's still angry. It's angry over here as well. Okay, it's angry at both of them. But yeah, so this fancy colon question mark syntax will display the option in debugging mode. And this should work. Great, it works. Great. Okay, so let's take a look at this. So I had a mutable, so to recap, I have a mutable reference called xref to this option. And when I call take on this mutable reference, it'll convert it to the actual option, and I'll have ownership over it now. And the result of take is sum5, which was what was there. And then now x is actually mutated. Now it contains none. So you can sort of see, like this is doing some sort of like moving around of memory under the hood. If you're wondering how this is implemented, under the hood it's doing some unsafe operations, and we're not going to like delve too much into like how this is implemented. It's like maybe in like a couple of weeks we'll talk about like unsafe Rust, and we'll talk a little bit more about how Rust handles like raw memory and stuff like that. But do the semantics make sense to people? Like I can have a mutable reference to an option, and when I call take on that mutable reference, it returns the option itself, not as a reference, but as an actual value, you can think of it, right? And what's left in the original option is none. Does this make sense to people? Any questions? This is totally confusing, by the way. I think it's not like super intuitive why this works or how it works. No, so take is defined on options. So actually, there's a more general, that's a great question. There's a more general version of take that will essentially, if you have a mutable reference to a particular type, it'll give you back that type, and it'll leave like a default value in its place. But we're not going to talk about that right now. If you're interested in learning more about that, if you look up like mem : take, that's what that will do. That's a great question. Yeah. Any other questions about this? So I'm going to comment this out for now. I'm going to comment this back in. So this is our buggy push. What do I need to do in order, like, given that that's what we just talked about? How do I fix this? Does anyone have any suggestions? Exactly. So let's see if that makes it happy. So if I close this, okay, so this is what we have so far. Self.head.take. What is that going to do? So we get a lot of warnings because we never use anything, but it compiles. So that's wonderful, right? So this was our solution. But are we done yet? Is this actually pushing it to the list? So what do I need to do now? Exactly. So I can set self.head is equal to new node. And I think this goes back to your previous question, Noah, about like how do I modify things inside of the struct. So you notice here, because I have an ampersand mute self, I'm actually allowed to do this. Does that make sense? Great. So I can do like self.head equals new node. And what I need to do one more thing, I would argue. So we're maintaining two pieces of state, right? How do I update my other piece of state? Exactly. So I'll do self.size plus equals 1. And let's see if it's just happy with this. No. Mismatched types. Oh, okay. So what's going on here? Why is it angry at me? It's because I did. So how do I fix this? Can someone tell me how to fix this? I wrap this one in option, right? So I'll say option box note. So this is definitely a mouthful right here. Maybe we'll move this over to the next slide so it doesn't go over. But now this should compile. Another thing I want to say, like, oh no, expected, what is it saying?
You have to wrap it in some.
In some. Oh, wait, yes, yes, you are totally right. Some box new. Right, so it's angry about
You
that.
have a value, and then when you put this inside of an option, you have to say, well, hey, this option is not none. It's actually like something. Here is the value that it is.
Another thing I could have done is I could have said this was the new node. I think, in my opinion, it's like slightly more idiomatic to say this. I'd say self.head is equal to some new node. This is what I would say, personally. But like it's the same thing, functionally the same thing, right? So if we run this, great, so that works. Another thing I want to say is like there's kind of this like fallacy like bubbling around where people are like, oh, the Rust compiler is like so hard to pass. Like once your code compiles, it basically is correct, right? Like that's not necessarily true. You should still test your code. We're gonna do that right now. So I'm gonna actually I'm gonna copy and paste the cheat right here. I'm gonna copy and paste the display function that I have already prepared. And let's see. Where is it? Where are you? And this is just going to print out our linked list. So the logic here actually isn't like too interesting. So that's why I didn't think we needed to like code it up together. But bam, right there. Okay. So this is just going to display our linked list so we can like verify to ourselves that it's doing this correctly, right? So one way to test this is I can say for I in 1.10 say I'm going to do first of all, I'll do list.push I, right? And then now I can do list.display. Does that make sense to everybody? So let's actually run that and let's see what happens. Cannot borrow list as mutable. It is not declared as mutable. Right, so the way we fix that is we say let mute list. Great. And now unused variable xref, right. Does that make sense to everybody? 9, so this is a stack, right? It's a stack, and it's going to be 9, 8, 7, 6, 5 because this is the reverse order in which we put things. Another thing to notice about this ... operator is it's 1.10, but that actually goes it's the first thing inclusive, second thing exclusive. That's the convention that Rust uses. Does that make sense to everybody? Right, and then now if I also do something like print ln list size, then I could also do like list.getSize, and that should output 9 if everything is correct, right? And we say that list size is 9. Perfect, great. All right, so we might have time for 2 last things. I'm gonna see if we get time, but let's see. Let's do public function pop is the other thing to implement right here, and this is going to return what? What do you think this should return?
A U32.
U32. Okay. What if my list is empty? Exactly. Option U32. Great. Now what does my implementation look like? Great. I definitely want a mutable reference to solve. That's correct. And now what? Well, so this is a stack. We just want to remove the first element. So we want constant time addition and deletion. But yeah, if I was doing like a queue or something, or like I guess like a backwards queue, I guess what would that be? Yeah, it would be kind of like a backwards queue, but yeah, exactly. Yes. Dot value. Okay. That would be fine actually. So this would be fine. I'm actually going to suggest that we do something a little bit different. Let's say that we should get like the node as like let node equals self.head.take, because we're going to be eventually sort of like we need this as like a value. We need this as an option. That's a great question. Okay, so if self.head is none, take is going to return none. That's a great question. So I'm going to show you all some cool syntax. There's this question mark syntax in Rust. And what it does is if self.head.take is none, then notice how this function returns an option U32. If self.head.take is none, this will just return out of the function after the first line, and it's going to return none. This is like very slick error handling syntax that you could use, right? Does that make sense? Right? And if it's not none, then node is actually going to be of type, it's going to be of type, well, it will actually unwrap it, right? So it will actually be of type box, sorry, yes, it would be a box node. So let's actually just compile that to here. So it compiles, I'm going to say like this returns none no matter what. But like let's just verify that the compiler is happy with that. So the compiler is happy with that, right? So what this question mark syntax will do is it will unwrap if it's some. If it's none, then it will just return none from the function. Does that make sense to everybody? This is kind of funky syntax, but this is like a nice way to avoid match statements, which, you know, like are another way to like handle errors and stuff like that. But this is considered more idiomatic for something like this. But notably, this works because we're returning an option U32, and this will return none. It will return this type if that doesn't work out. Does that make sense? Okay, great. So we have this node. What kind of pointer rewiring do I need to do? We can do this in the last minute. Exactly. So self.head is equal to, we'd say node.next actually, right? Because we have this node from earlier here. But if we do, yeah, does that make sense? Because if we do self.head.next, we might, well, actually, let's see what the compiler tells us. If it's happy with that. It's angry because it's it's an option, right? So you need to take it out of the option, and that's what we did up here. But that's like a reasonable thing to try out there. So node.next, and finally we need to return this value. How do I return this value? The value of the thing that we just popped off. Right, okay, so I would say sum of what? Exactly, sum of node.value. Let's just make sure that compiles. And before we go, let's just test this out real quick. So if I do println bang of, let's say, like first element. This will be, or I guess top is a better, top element is going to say list.pop. I'm going to say unwrap here because we know it's not empty because it's returning an option. Then if I do list.display again, let's just make sure that this makes sense. So I'm going to run this. Great, so top element was 9, and now the list is 8, 7, 6, 5, 4, 3, 2, 1. Great. That's okay, great. We didn't, we forgot to. I will do that. So let's see, so we'll do this one, and we'll just say self.size minus equals 1. Great. And I realize I also committed an error in the lecture notes, so I will update that as well. But now if we do println bang, size, we do list.get size, then we should also see that that has decreased to 8. So if we look down here, exactly. So list size was 9, the top element was 9, we popped it, now it's 8, 7, 6, 5, and the size is now 8. Great. Does that make sense to everybody? This is a really involved example. It's a lot of new concepts that y'all haven't seen before, but you'll definitely see again in this week's exercises. I will share a link to this so that you can play around with this yourself, and you can, maybe you want to define like a copy function for your linked list. Maybe you want to, see if you can like get generics working with it if you want to study up on that. But yeah, that's all for this week. Please stick around if you have any questions.